insight from there. All right, let's go ahead and get on the next question, which was solving trigonometric equations. So again, a lot of students, happens every year, they have trouble solving and they start making mistakes with inverse operations. So one thing, I reminded my students again this year was we practiced all of these. 4x squared minus 1 equals 0. Like, what would you do if you're in algebra 1 and algebra 2? Well, you're going to isolate your variable, right? And you're going to isolate your variable either by inverse operations or by factoring. And this one you could actually do by factoring if you wanted to, but most students usually don't look at factoring first. They usually look at factoring last. And so as long as we can apply inverse operations and we're not faking or making anything up, then typically inverse operations a lot of times are going to be an easy solution. Again, you can usually use inverse operations, or you can use inverse operations when you only have one variable here, in this case, x. So therefore, this is going to be plus or minus, let's see, that's going to be the square root of 1 over 4. Uh-oh. Now, it is very, very important that you recognize this, that again, this can be broken down into plus or minus the square root of 1 over the square root of 4. Now I'm getting into myself, which can be broken down into plus or minus 1 over 2. Okay? I don't know why. All right, whatever. I was thinking the answer in my head was something else. So either way, that's the exact same idea we want to do with trigonometric equations. We want to isolate our trigonometric function either by inverse operations, typically if there's one, or by factoring if there's going to be typically more than one. But hopefully you recognize the same operation here. So it doesn't matter if it is with the x or with trigonometric functions. Now the one thing that usually some students do have trouble with is sine squared of theta. Remember, that's just equal to sine of theta quantity squared. Okay, so that's just our notation. So therefore, it is sine of theta squared, just like x squared. So therefore, we are going to want to take the square root. So therefore, we have sine of theta is equal to plus or minus 1/2, right? I already kind of did the breakdown for you. So now we need to understand all right, we need to find all the values that make this equation true. And we're just going to find them on the unit circle. Between 0 and 360 is basically the unit circle. So what I'm going to do is I'm just going to sketch the graph of the unit circle. And I'm going to say, all right, since I know my unit circle so well, I need to find all the values when sine of theta is plus or minus 1/2. So the easiest way to do this is to look at the first quadrant, because if you know the angle in the first quadrant when sine of theta is equal to 1/2, which is right there, which is pi over 6, then all the other angles that are going to have sine of theta equal 1/2 are going to have the same reference angle of pi over 6, meaning they're going to be pi over 6 away from the x-axis. So that's going to be over there. That's going to be over there. And that's going to be over there. Now, since these angles need to be positive and between 0 and 360, I'm just going to say, all right, well, if halfway around the circle is pi, but I'm pi over 6 short, pi is 6 pi over 6. So therefore, we could say, let's do a solution set here. So I'll say pi over 6. Halfway around circle is 6 pi over 6, which would be pi, minus pi over 6. So that's going to be 5 pi over 6. Halfway around circle is pi, or 6 pi over 6, plus pi over 6. So that's going to be 7 pi over 6. And then all the way around the circle is 2 pi, which is equivalent to 12 pi over 6, but minus pi over 6 away. That's going to give us